Okay, so we're going to graph a quadratic in vertex form. So we have this quadratic that is in vertex form. We have to remember that vertex form says that we have a times, would look like this. This is what vertex form looks like. A times the quantity x minus h squared plus k. And we know that the vertex, in this case, the vertex would be equal to the point hk. This throws people off a ton because this is the form of it. This is what that form looks like. So we got a positive 2 here. So people think the h value is positive 2. But if you look at it this way, for just a second, we look at this, we say h is like a Christmas present. It's in a box. So what number would you have to put in this box? Think about this carefully. What number would you have to put in this box to make this thing go to plus 2? If you put positive 2 in there, look what would happen. So people say, oh, h is positive 2. If we put positive 2 in there, we get negative times a positive is a negative, and this would be negative 2, wouldn't it? So that doesn't work. But if we let h be negative 2, negative is positive. Positive 2. Therefore, the h value is negative 2. If that didn't make sense, rewind the video and look at that part again, because this is the part that throws everybody off. The most common mistake I see made is that one. So you can do this, but you got to kind of take a second and roll back and look at that again. The k value in our case is 5, so we know we have this. So far we have this, don't we? So we have this thing is going to look like this a little bit. So here you have our Cartesian plane over here, and we know we have the point negative 2, 5. Whoops, sorry. The point negative 2, comma 5. We have that on our graph. We also know that this a value is negative. This is negative 1/4. So we know that based on that, we know that our parabola is a maximum parabola, so it has this kind of shape to it, right? So it's concave down. It's a maximum parabola. So the next thing I'm going to do is I'm going to choose some x values just so I can start closing on this. How am I going to choose these? I like to choose one to the right, one to the left. So I'm going to choose x is 2, y again just because I like to. So I'm going to solve here for f of 2. So f of 2 is negative 1/4 times x. We said x would equal 2, so I'll put the 2 there plus the 2 that was already there squared plus 5. And if we look at that, we'll get 2 plus 2 is 4. 4 squared is 16, so we get negative 16 over 4 plus 5. This is negative 4, isn't it? Equals 1. So we would get the point 2, 1. So here's maybe 2, 1 right here. So we can extend our parabola here like this, can't we? See, this thing looks like that, right? And I like that. I think, don't you? Is 1. Now, I did a little bit of thought my way through this a little bit more, so this is not really off the top of my head. Now, if you don't mind, I'm going to take x is equal to negative 4. The reason I chose negative 4, you'll see in a minute, but not the least of the reason is I want something on the left-hand side to graph also. So I chose x is negative 4, so I'm going to solve for f of negative 4. We get 1/4. This is the x value, says x goes here. It's negative 4 plus 2 squared plus 5. Hopefully you can see the similarity here, because negative 4 plus 2 is negative 2. Negative 2 squared is 4, isn't it? Right? Negative 1/4 times 4 is negative 1 plus 5 equals 4. So we'll get the point negative 4, 4. Negative 4, 4. I'm just going to draw through that and finish my parabola off like that. All right? There are lots of ways to do this, and I want to be clear with you that this is not the most precise way. There are more precise ways of me doing this. I'm not using them right now. Right now I'm just using the vertex form, and I'm using little tiny tricks to get this graph. But it is helpful, and it is the way that it's often done. So I hope this was really helpful for you. Thanks for watching.